All right, folks, this is a couple of hopefully quick things about what the center of mass means conceptually. So the first thing is that in order for something to stay balanced, the center of mass of the object needs to be over the support base. So if you ever go see Cirque du Soleil or any of the other events where you would see the contortionist, they're not just showing you how flexible they are, since this is your support base between this person's hands. The center of mass must be directly above that area, somewhere over that area, or that we'll see later on that will cause torque that will make it tip one way or the other. So this person's legs go out to the, let's say, to the right, and then this person's torso needs to go to the left, so that on average the center of mass is over the hands. Okay, same thing. You can see the videos if you want, just watch the slide deck. But this tightrope walker, this person that is balancing on top of their head, they put one leg this way and one leg that way, so that on average the mass is still, again, over the hand of support. Okay, and then you can do wheelies and still stay balanced. So again, you can see the videos on the original slide deck if you want. In terms of drawing force diagrams, once we do torque, when we do the torque unit, this is a ladder that has mass and a firefighter that has mass. CM stands for the center of mass. So they're showing you the ladder's center of mass is not quite at the midpoint of the ladder, because maybe there's, like legs at the bottom to keep it stable. Anyway, for whatever reason, it's more heavy towards the bottom. They're telling you where the center of mass is. When you draw the weight vector, you need to draw it at the center of mass of the ladder. When you draw the weight of the firefighter, you need to draw it where the firefighter is. And the reason is that we're going to see that torque is about force and the distance to the pivot. And so this, what we're going to call the lever arm, points to the center of mass. I know that doesn't mean anything to you now. I'm just trying to give you a heads up. So it's really important that you know where the center of mass is, so you know the distance between the center of mass and where the thing's going to pivot. Okay, so short story is, when you draw mg, you should draw it at the center of mass. In terms of energy, whenever we said mgh, what we meant was the center, that we want to find the height of the center of mass. So that is how you calculate an object's gravitational potential energy. So in the olden days, this is how people used to jump over the high bar. They physically jumped over it. And then there's a person named Dick Fosbury who figured out how to, by jumping over the high bar this way, the center of mass is actually below the bar, which means that the mgh that's required is less, because the height is less. It's actually below the bar as opposed to way, way, way above the bar. Okay, so then I just kind of guesstimated where, photoshopped where the center of mass was, and assuming these bars have the same height, which they're different pictures, but you can see that this person is that much above the bar and this person's actually that much below the bar. So this is going to take more energy. Okay, and then you can look up Dick Fosbury. You can see the video on the original slide deck, but the trick of the Fosbury flop is that the center of mass actually goes below the bar. Okay, and then the last thing, a couple more things, is when something is moving through space, what this physics teacher did was they took a baton and they spun it in the air, and they had a green LED on one end of the baton and a yellow LED at the other end and a red LED at the center of mass. And then I scanned this in and photoshopped it, so that's why it looks so goofy. But the center of mass follows a beautiful arc, which is what you think something does when you say that it goes in the air. We haven't done projectile motion unless you've prepped for the AP, but the center of mass behaves as though it's the particle and everything else rotates about the center of mass. Okay, and then same thing, this is a bird's eye view of a wrench, and if you throw the wrench so that it has rotation, the white little dot here is the center of mass, and that's going in a straight line. In theory, each little one of these dots is an equal distance away if it's traveling at a constant speed, and the wrench rotates about the center of mass. But the center of mass itself travels as though it was the particle that we were talking about. Okay, and then this is just an animation similar to the LED one, but the hatchet, if you're hatchet throwing, the center of mass of the hatchet travels in a beautiful arc, but the hatchet rotates around that point. I think that is it, and just some of the conceptual things that are important to know about center of mass. Thanks for listening.